I think definitions like static friction is one of those things that people overlook, right? People usually concentrate on Newton's first law, second law, third law, so on and so on. But these kind of definitions are definitions that people oftenly overlook. They don't really give themselves some time to actually go through and memorize these kind of definitions. So I'm expecting that a lot of people actually got 2.1 wrong. But anyway, stories. Let's take a look at 2.2. Draw a labeled free body diagram showing all the horizontal forces acting on the crate just before it starts moving. Right. 2.2. Just like 2.1. People are not paying attention to the details. So I think that this is another question where people got it wrong. But most people think they got it right, but they actually got it wrong. Let me show you why. So 2.2, the key word here is horizontal, right? We want to draw a free body diagram showing all the horizontal forces. So if you include the vertical forces, I'm assuming you'll probably get it wrong, right? You'll probably lose 1 mark for every vertical force that you include. I think that's probably what's going to happen. So if you include the normal force and the weight, I think you're going to get nothing, or at most 1. But I'm quite sure there's no way you get all the marks if you include the vertical forces. So free body diagram for this object. Let's read through the question statement and see what is happening. In an experiment, a crate of mass 8.5 kg lying stationary on a rough horizontal table. So already we know that we are supposed to have friction, right? Because it acts horizontal. It is connected to a mesh hanger by means of a light inextensible string passing over a frictionless pulley, as shown in the diagram below. Mesh pieces are added to the mesh hanger and the acceleration of the crate is measured. The experiment is repeated several times by adding different meshes to increase the hanging mass each time. Ignore the effects of air friction. So right, that is the information we have. And then we're supposed to draw a label free body diagram acting on the crate just before it starts moving. Okay, so obviously we have the tension, right, as a consequence of the light inextensible string that connects the crate and the mesh hanger. And then we also have frictional force, right, acting on the object. So there we go. These are the only 2 forces that we're supposed to have: frictional force and the tension force. Right, no normal force, no horizontal force. Not because they are not there, not because they do not exist. They still do exist, but the question is saying only the horizontal forces. So we have to respect that. And then 2.3.1. We're supposed to calculate the coefficient of static friction. So we are looking for this coefficient of static friction. So we already know fully well that the static frictional force is equals to the coefficient of the static friction multiplied by the normal force. The coefficient of static is usually greater than the coefficient of kinetic. Right. You will see why I'm mentioning that in this question as we do 2.3.2. So what information do we have? Do we have the frictional force? Maybe. Let's take a look and see what we have here. We are actually not given the frictional force, right? The static frictional force. So how the hell are we supposed to calculate it? But do we have the coefficient? The coefficient is what we're interested in. So obviously we don't have that. What about the normal force? Well, the normal force, we can calculate it, right? Because there's no Fy, the normal force is just going to be equals to the weight. So the normal force, 8.5 multiplied by 9.8. So let me just put this in my calculator and see what happens. My calculator is in scientific, so let me put it back to normal. So we have 83.3 Newton. This is the normal force. And then the coefficient is what we're interested in. So how can we calculate the static frictional force? How can we possibly calculate that? Okay, let's take a look at our scenario here. In 2.2, we have a free body diagram, right, of the crate just before it starts moving. Just before it starts moving, the frictional or the static frictional, it is supposed to be, because it's just before it starts moving, should be equals to the tension, right? But how can we calculate the tension? We are given this diagram here, right? You can see that when the hanging mass is 4.2, our crate starts moving, because that's where we start having a bit of acceleration, right? Right here at 4.2. So the static frictional force is equals to the tension, right? But the tension here on the mass hanger with the mass pieces is just equals to the weight, right, of that object. So that is, what is the mass of that thing? Let's take a look. The mass is 4.2 when we start having an acceleration, and acceleration due to gravity is 9.8. So we have 4.2 multiplied by 9.8, which is equals to 41.16. So we have the static frictional force. So now we can see 41.16 is equals to the coefficient multiplied by 83.3. So the coefficient is going to be equals to 41.16 divided by 83.3, which is equals to 0.49. So that is 2.3.1. Let's take a look at 2.3.2. We are looking for the magnitude of the acceleration represented by y on the graph if the coefficient of kinetic friction between the crate and the table is 0.4. So take a look at this. The coefficient of kinetic friction is 0.4, and we calculated the coefficient of static friction to be 0.49. So we are quite convinced that the answer we have in 2.3.1 is correct, because if the coefficient of kinetic friction was greater than this one for static friction, we should be worried, because we know fully well that that should not be the case. So there we go. We have the coefficient of kinetic friction, and then what else do we have? We are looking for the acceleration at y. So we do have the mass, we have the hanging mass, right? So the hanging mass is equals to 7.4. Let's concentrate on the crate. If we concentrate on the crate, F net is equals to ma. We know that fully well. And then the force that is pulling the crate is the tension minus the frictional force that opposes. And this is equals to ma, right? So what is the tension? We don't have the tension at this point. What about the frictional force? We have the coefficient, right? So this is 0.4 multiplied by the normal force, which is 8.5 multiplied by 9.4, 9.8, 83.3. So we have 83.3, and then this is equals to 8.5a. So tension minus, so 0.4 multiplied by 83.3, and this is equals to 33.32, and this is equals to 8.5a. Okay, so it seems like we are in a we are stuck here. We have the tension, we have the acceleration, and we have two variables, right? So we need another equation. So let's concentrate on the mass hanger. The mass hanger, the free body diagram, it should be the weight and the tension, right? So why is it going down? It is going down because of the weight. So weight minus tension is equals to 8.5, not 8.5a, but the mass of the hanger, which is 7.4a. So the weight 7.4 multiplied by 9.8 minus the tension is equals to 7.4a. Okay. Obviously, in place of tension, we can substitute. We can make the tension the subject of the formula in this equation. So it is going to give us 8.5 acceleration plus 33.32. So instead of having tension there, we can say 7.4 multiplied by 9.8, which is 72.52, minus 8.5a minus 33.32 is equals to 7.48. So minus 8.5 minus 7.4, and that is minus 15.98. This is equals to 72.52 minus 33.32. It is equals to 39.2. But when you take it to the other side, it is going to be minus 39.2. So the acceleration is equals to minus 39.2 divided by 15. Is this 15.9 or 15.19? I forgot what that it is, what I wrote there, because it's not clear. So minus 39.2 divided by minus 8.5 minus 7.4. I can just do that because I'm not sure what I wrote there anymore. So the acceleration that I'm getting is 2.47 meters per second squared. That is the answer to 2.3.2. And here's the question for you, 2.4. A 5 kg block is now placed inside the crate and the experiment is repeated. How will this affect the maximum static frictional force now experienced by the crate? Okay, choose from increases, decreases, or remain the same. Give a reason for your answer. So what is your answer to 2.4? And why are you saying so? Apart from that, let me know which question you want me to do next. Here we go.